Welcome to ACT Math Prep, Day 31. Hopefully you either have your bell ringer sheet or you are going to look at the screen and use notebook paper. So the first one is going to ask you to simplify. A little hint here, you're going to FOIL, first, outside, inside, last, to make these trinomials. And on the bottom, you're going to use the distance formula to find the distance between the 2 points. So hit pause on your computer. Take about 5 to 10 minutes to answer this. And when you're done, unpause, and we will go over the answers. Okay, welcome back. Let's check these answers. So the first one, I'll go over the first one with you. We are going to do FOIL. So that is where you multiply the first two numbers. X times X is going to give us X squared. Outside, -2 times X gives us negative, oops, that's a terrible 2, negative 2X. 3 times X gives us positive 3X. And then outside, 3 times -2 is a -6. We can combine these like terms. -2x plus 3x gives us positive x. So that's where we get x squared plus x minus 6. Now, the next one, when we get down here at the bottom, you're going to be using the distance formula. And I just popped it up there for you. Yeah, this is not one of my favorite formulas because it just looks complicated. I always teach my students another way to set it up. You're following the same formula. You're doing things the exact same. But to me, this just works in my head better. And what I do first is I stack my numbers. So 2, 1, and then the origin is going to be 0, 0. And if you look in our formula, the first thing we do are subtract the x's and subtract the y's. So I'm going to go 2 minus 0 gives me 2, and 1 minus 0 gives me 1. After we subtract, what do? We square them. So what's 2 squared? It's 4. What's 1 squared? It's 1. After we square them, we do what? We add. So then I get 5. And the very last thing I do is take the square root. I have a lot of students that prefer it this way because it looks better. It's stacking, it's doing math. It keeps them from getting the x's and y's mixed up as to which one should subtract from the other. Yeah, so you can use that with any of them. Any of them here. Okay, hopefully everybody got them all right. Yes. So today we're going to talk about asymptotes. All right, and you're probably going, why are we learning asymptotes? Oh my gosh. Well, yeah, this is about functions, and asymptotes are basically a boundary. Okay, think about if you had your dog on a leash. Isn't there a boundary? They can get up to a certain point, but they can't go past. That is what an asymptote is on a graph. Okay. So an asymptote can be like a curve, and it can approach the line but never really touch the line. It can get as close as you possibly can as long as they're not touching. Okay? There are 3 types of asymptotes. And this is what I need you to know for the ACT. We're not going to do major hard ones, but I need you to know there's 3 types of asymptotes. Okay? The first one is a horizontal asymptote. You can see it here. Both these graphs approach y equals 2, but they're not going to touch it. The second one is a vertical asymptote. You can see it here with the blue dotted line. Both of these are going to approach y equals -1, but they will never intersect with it. And if it's not vertical or horizontal, what's the other option? You probably said diagonal. That's what I've said too. But we call it oblique or slant. Oblique or slant. Which to me, you're either horizontal, vertical, or you're on the diagonal. So if you're given all 3 choices, you can figure out from the test. Oh yeah, that's right. They call it oblique. So basically what you're going to want to know is you should be able to look at an equation and identify does it have a horizontal asymptote, a vertical asymptote, or a slanted. And it can have all three. It can have one, it can have two of them, or it can have three. Now, basically we get asymptotes when there is a variable in the denominator, because this all comes from, can you divide anything by 0? No. What is 3 divided by 0? It's undefined. So we can't do it. So these problems are going to deal with graphing a problem where there is a variable in the denominator. Because if x is equal to -2, what's -2 plus 2? 0. We get 4 minus 0. It's undefined. And that's our asymptote. X is -2. So to find a vertical one, if there's an x in the denominator, doesn't matter what else, all you do is you set the denominator equal to 0. So x plus 2 equals 0. Move the 2 over. X equals -2 is the vertical asymptote. So every time you have a variable in the denominator, you will have a vertical asymptote. Here is this one graphed. Okay. They can approach x is -2, but they will never intersect because that is where it's undefined. Now, let's talk about horizontal asymptote. A function is going to have a horizontal asymptote of exactly y equals 0. That's the x-axis. If the power of x is larger in the denominator. Okay, I know I talked a little Swahili there, so let's look at an example of what I just said. Here we have x in both the numerator and denominator. Now I'm going to interject here a little. Does this have a vertical asymptote? Yes, because there is a variable in the denominator. So if I set x squared minus 3 equal to 0, I get 2. I actually get 2 vertical asymptotes because I get x squared is equal to plus or minus square root of 3. But this will also have a horizontal asymptote of y equals 0 because look, the power x squared is greater than x to the 1. So that means I have a horizontal asymptote of exactly y equals 0. That's the beauty of it. I don't even have to calculate it. It's y equals 0. So when the exponent in the top is smaller than the exponent in the bottom of your variable, horizontal asymptote, y equals 0. So right now I can tell you this one has 3 asymptotes. It has 2 vertical, 1 horizontal. Okay. Yep. Here you go. Here's how we find the vertical. Set that denominator equal to 0. X squared is greater than x, so we have y equals 0. And here is going to be your graph. So these are approaching the x-axis. That's y equals 0, but it's never going to touch. And then we have, like right around here is negative square root of 3. Right here is positive square root of 3. They're going to get really close, but never touch. Yeah, this is some algebra 2 stuff. But we're just dealing with the asymptotes. Now, the next one you've got, if the powers are the same for your variable in the numerator and denominator, we're going to look at the coefficients. So let's look at this one. If we look at our variables, they're the exact same. It's x squared on the top, x squared on the bottom. Woo, like that. Will this have a vertical asymptote? Yes, because there is a variable in the denominator. Set that denominator equal to 0, and we get our vertical asymptotes. Okay? So, set the bottom equal to 0. We get 2 vertical asymptotes, plus or minus square root of 3 over 3. When these are equal, here's the beauty of this, because you're probably going, how am I supposed to calculate what the answer is? It's not rocket science. It's the coefficients out front. So since they're the same, x squared over x squared, the answer is y equals 2/3. Again, we really haven't done any hard math, but this is a lot to memorize. And so this one's going to look like this. Here we've got our horizontal asymptote of y equals 2/3, and we have our two verticals of plus or minus square root of 3 over 3. Yep, it's kind of crazy. Now, the last one is going to be the oblique. Okay, so we've had 3 scenarios so far. If there's a variable in the denominator, you will have a vertical asymptote. Set that denominator equal to 0 and solve. You can have one or more vertical. If it's horizontal and the power in the denominator is greater than the numerator, so you have x over x squared, you have a horizontal asymptote of y equals 0. That's the x-axis. If you have, say, 2x squared over 3x squared, the x squareds are the same, the horizontal asymptote will be the coefficients, y equals 2/3. Now let's talk about an oblique one, okay? So, okay, if the power of x is larger in the numerator, you have to use long division. So the whole number portion of the division result is the oblique asymptote, okay? This one's a lot harder. But you basically need to be aware of what type of asymptotes go with each equation rather than solving, okay? And this one's more complicated. You're not going to see questions for the oblique other than being able to say it has an oblique asymptote. So here's this equation, okay? You've got x squared in the numerator, x in the denominator. Do we have a vertical asymptote? Yes. There's a variable in the denominator. Set it equal to 0. Vertical asymptote of x equals 3. We do have an oblique one here because it's greater in the top than the bottom. Okay, and that's really what you just need to know. What is the equation of that line? That's not as important as, yes, it has an oblique asymptote and a vertical one. All right, so you've got 5 questions. Oh, sorry, I put that slide too soon. I thought I did. Let's do our ACT example. So here, this is what you're going to see. What type of asymptotes does this function have? Pause the video, see if you can get the answer, and then unpause and we'll go over the answers. All right, welcome back. Well, the first one you should notice is I've got a variable in my denominator. So yes, I'm going to have a vertical one. I only have 2 answers. Got a 50-50 chance of getting it right. So now you have to ask yourself, and this could kind of help me out here on the test if I'm like, oh, God, I don't remember. Is the exponent supposed to be greater in the numerator or greater in the denominator? I know there's 2 of them. Well, right now I've got my answer. X squared over x, the only choice I have is vertical and oblique. So when it's greater in the numerator than the denominator, that's a slant. If it was greater in the denominator than the numerator, that would be horizontal, y equals 0. Yep. And again, I really didn't have to solve for that vertical asymptote. It just wanted me to know that there was one there. Okay, so now you've got 5 questions. Set a timer. You can use this timer or set a timer on your watch for 5 minutes. Take your time. If you need longer, that's okay. And when you're done, unpause the video and we will go over the answers. Okay, welcome back. And let's look at the first one. What are the vertical asymptotes? Now, this is one they will ask you to calculate because it's pretty easy. We just take the denominator and we set it equal to 0. So we're going to move the 1 over and we get x squared is equal to 1. Take the square root of both sides. So x is going to be equal to plus or minus 1. Okay, so our answer would be E. plus or minus 1. And this is a great one where you want to make sure that you look through all the answers because you don't just want to go, square root of 1 is 1 and forget the whole plus and minus thing. Second one, what is the horizontal asymptote if there is one? I hate these questions because look at K and it makes me go, is there not one? It makes me second guess myself. But I remember this and I know, okay, X here, X squared, we just kind of did the practice one where I knew if it was greater up here and lesser here, that was oblique. So yeah, here we've got one and they're not the same. So that horizontal asymptote is y equals 0. When it's greater in the denominator than the numerator, the asymptote is y equals 0. So here, let's go. What type of asymptotes does this have? Obviously, we've got an X in the bottom, so there's a vertical. They are the same, and I remember that is a what? Horizontal, because this is the example where that horizontal one is y is equal to 3/4. It's the coefficient when they're the same. Because you can almost think of it like, those cancel. There's my equation. So the answer here is D. Now this one's a little bit tricky. Where do the vertical and oblique asymptotes intersect for this function? And what I'm going to do here to not have to solve it fully, I'm going to solve for my vertical asymptote. And I get 2x minus 2 is equal to 0. So 2x equals 0. Oh, sorry, gotta move it over 2. So x is equal to 1. So I can come over here and I instantly know it's not these. Okay? I instantly know it's not those. Then I also know here, if you look, you've got a 1 here. And so that's going to tell me it's the 1/2. You've got 1 over 2. We ignore like the sign and we know that that answer is 1 minus 1/2. And that's kind of how I cheat it without having to completely work the whole thing. Okay. The other way you can do it, once you get x is equal to 1, you can plug 1 in here and then solve there. And that's going to give you negative 1/2. That would be another way. So complete your exit ticket. Now the exit ticket is multiple choice and it's basically going back to those rules in your notes and what we went over in the video. What are the conditions for a vertical asymptote, horizontal of y equals 0, a horizontal asymptote where it's y is equal to those coefficients, and then an oblique. If you have any questions, you can shoot an email to your teacher or ask for help in class. And hope you enjoyed that lesson, and we'll see you for the next one.